Okay, we're going to start talking about circuits. The first type we're going to talk about is a series circuit, and in order to do that, we first need to look at schematic diagrams, okay? So we just need to understand what everything is. Okay, when we draw a circuit, we're going to draw a battery like this. So this symbol represents a battery, okay? This symbol represents a light bulb. And this symbol represents a resistor. Okay? The battery, the shorter end represents the negative terminal, and the longer end represents the positive terminal. In a light bulb, you can kind of look at it. This looks like the filament inside of a light bulb, and then the circle for the actual light bulb. And a resistor is a jagged line slowing down the flow of the electrons. Maybe it kind of looks like a speed bump to you. Okay? So those are the main symbols that we'll be using. Okay? So when we go to draw our circuit, what we're going to do is we're going to put our battery in, and then we're going to attach some wires. Now notice, these wires don't look like the wires would in the table. They're like not all curvy and flowy, okay? When we draw the drawing, all of the time, every time we turn, we make an angle of 90 degrees, okay? So all the wires need to make angles of 90 degrees. In this top drawing, we have got a closed circuit, a closed loop here, which means that our light bulb is going to turn on and light up, okay? Why is it closed? Well, this side of the light bulb is connected all the way to the battery, and also the other side is connected all the way to the battery. So we've got a closed loop there, and therefore the light bulb is going to turn on. Down here, if you look, the light bulb is connected on the right side to the negative terminal of the battery, but on the left side, there's this open gap. This is an open circuit, and this light bulb will not turn on because the electrons need an entire loop to travel through. And here, they don't have anywhere to go, okay? So the potential difference is not connected. So what do we know about a series circuit? Well, in a series circuit, if you unscrew one light bulb, all the other light bulbs go out. And that should make sense based on what we just did. Okay, here's the battery. We go up, we go to the light bulb. They go through, come down, go through. All of these work. I take this first one out. Now I've got a gap. Okay, yes, this side is eventually connected to the battery, but the top is not. We've got a gap here. Okay, so this is an open circuit, and therefore the light bulbs will not turn on because there's no flow of electrons. Put this back in. Oops. Put our light bulb back in and connect everything, and now all three light bulbs would turn on. A couple of other things about a series circuit. The first one, the current in a series circuit is the same everywhere. Now this is the current at the battery, if there is no subscript, and then each of the subscripts tell you the current at different spots, like the current at the first battery, the second battery, the current at the first light bulb, the second light bulb, and the third light bulb, okay, the subscripts. But in a series circuit, they're all the same, okay? You can kind of think of it as being a one-lane road, okay? You're the first electron, and you're going around, and the second one cannot go around you, cannot pass you. There's only one path. So therefore, you're all going to end up going the same speed, okay? Resistance, on the other hand, is a little bit different. Again, this is the equivalent resistance. This is the resistance that if you took out these three light bulbs and you put one light bulb in to replace them, it would be equivalent to these three, okay? So this is what the equivalent resistance is. It's the total resistance of all the electronic devices. In a series circuit, to find the equivalent resistance, all you have to do is add up the resistance for each of these. So maybe you got 2 ohms plus 3 ohms plus 4 ohms, okay? Just add them all up. It's very simple, okay? And then the last thing is Kirchhoff's voltage law. The voltage drops and gains across a closed loop is equal to 0. Okay, voltage drops and gains. In this class, we're going to say that batteries are always a voltage gain, okay? If you take more advanced classes, it could be one where it's a drop. But right now, all of our batteries are going to be voltage gains. So maybe this is a 12-volt battery, okay? We gain 12 volts of the battery, Okay? What Kirchhoff's law is saying is that the voltage drops around need to add up to be 12 as well, so that by the time we get the whole way around, we've lost all of our 12 volts. Okay? So these three would have to add up to 12 volts as well.